Hey there! Welcome to Programming Life. Let's make something awesome. Alright, let's start by creating a new Java class, and we'll call it Flower Growth. This class will be responsible for drawing and animating our flower using Java Swing. Now, at the very top of your code, we need to import a few important libraries. Swing lets us use Swing components like JFrame and JPanel. AWT gives us access to basic drawing tools like colors, shapes, and graphics. Event allows us to handle events, such as timers and actions for animation. Next, let's make our Flower Growth class extend from JPanel and implement the ActionListener interface. We'll move on next to adding the timer and the drawing logic. We start with a variable called petal length, set to 30. This will control how long each petal appears when the animation begins, and it will gradually increase as the flower grows. Next, we have max petal length, which is set to 120. This defines the maximum size our petals can reach. Once the animation hits this value, the petals stop growing. Then, we declare center radius, set to 20. This determines the size of the flower's center circle, which will stay fixed while the petals expand around it. Finally, we have the timer object. The timer is responsible for updating the animation at regular intervals. It's what creates that smooth, natural growth effect as each frame is drawn on the screen. In the constructor, we're setting up the initial environment for our flower animation. First, we define the background color, a soft, light blue that gives the flower a fresh, sky-like backdrop. Next, we create a new timer object, which runs every 75 milliseconds and triggers the animation updates. Finally, we start the timer, and from this point on, the animation begins running automatically as soon as the program launches. Now we're overriding the paint component method. This is where all the drawing happens inside our program. The very first line calls super.paint component, which clears the screen and prepares the panel for a fresh frame before we start painting again. Then, we create a graphics 2D object from the graphics parameter. This gives us access to smoother, higher quality rendering tools, allowing us to draw shapes, colors, and effects with much finer control. Here we enable anti-aliasing for our graphics. This smooths out the edges of shapes and curves, removing that jagged pixel look. It gives the petals and the entire flower a softer, cleaner appearance on screen. Next, we calculate the exact center of our panel by dividing the width and height by 2. These values, x center and y center, give us a perfect middle point, the reference for all of our drawing. Then we set the color to yellow, and draw a filled oval right at that center position. This becomes the heart of our flower, a steady, bright circle that stays fixed while the petals animate and grow around it. It acts as the anchor point for the entire design. Now we set the drawing color to pink and define the number of petals as 8, giving our flower a soft, balanced look all the way around. Now we begin the loop that draws each individual petal of our flower. Inside the for loop, we repeat this process 8 times, once for every petal. The first step is to calculate the angle for each petal. By dividing a full circle, 2 times pi, by the total number of petals, we find the exact position where each petal should appear. Then we multiply that angle by the loop index I, so each petal rotates evenly around the center. Next, we calculate the x and y coordinates. Using a bit of trigonometry, we take the cosine of the angle for the x position, and the sine of the angle for the y position. Both are multiplied by the center radius, and then added to the x and y center values. This positions every petal perfectly around the center circle. After that, we set up 2 more variables, petal width and petal height. The width controls how wide the petals look, while the height, which is linked to petal length, determines how far they extend outward as the animation grows. Now comes the fun part, actually drawing each petal. We use translate to move the drawing cursor to the petal's position. Then rotate it by the current angle so each petal points in the right direction. Once rotated, we draw the petal using fill oval, centered horizontally and extending outward from the center. This gives it that natural, symmetrical look you'd expect from a real flower. After drawing the petal, we undo the rotation and translation. This resets the graphics position before moving on to the next one. That way, each new petal starts from the proper base orientation, without the previous rotation affecting it. The loop continues until all 8 petals are drawn, evenly spaced, smoothly rendered, and perfectly surrounding the yellow center. By the time this loop finishes, you'll see a complete flower, ready to come to life once the animation begins. Now we move into the action performed method. This is what drives the animation forward. Each time the timer triggers, it checks whether the petals have reached their maximum length. If not, the petal length increases slightly, and the panel repaints to show the new frame of growth. Once the petals reach their final size, the timer stops, freezing the flower in full bloom. Finally, inside the main method, we set up everything our program needs to bring the flower to life. We start by creating a new JFrame, and give it the title Petal Growth Animation. This frame acts as the main window where all of our graphics will be displayed. Next, we set the default close operation to exit _ close, ensuring that the program ends completely when the user closes the window. Then we define the size of the frame, 540 pixels wide and 400 pixels tall, giving us a comfortable canvas to show the animation clearly. After that, we add a new instance of our flower growth class to the frame, which connects our drawing and animation logic to the display window. Once everything is in place, we make the frame visible, so the animation appears on screen. And finally, we call setLocation relative to null to center the window perfectly in the middle of the screen, giving it a clean and balanced look as it starts up. With that, our full program is ready, the frame loads, the timer begins, and the flower starts to bloom beautifully at the heart of the window. We add our flower growth panel, make the frame visible, and center it on the screen. And with that, our flower animation is complete. Thank you for watching.